Good morning, good afternoon, and good evening to everyone. So welcome to the latest edition of the COGEN World Talks webinar series, organized by the COGEN World Coalition, CWC. We're quite excited today. We're going to be presenting the results of a study that COGEN World Coalition recently commissioned, focusing specifically on efficient energy solutions for data centers and the role for cogeneration or CHP. So we have an excellent lineup of speakers, beginning with a presentation by Simon Minett, presenting the results of the study from Challoch Energy, followed by three presentations from different energy technology providers, different perspectives, different, let's say, experiences on this issue. So we have a packed webinar. It should take us about 2 hours. Just to let everyone know, we are recording this presentation, so should you not be able to follow the full length of the webinar, or a colleague or friend cannot participate, this is being recorded and will be made available on the CWC website, but also will be promoted via the social media channels managed by CWC. There'll be two Q&As, one following directly after the presentation by Simon Minett from Challoch Energy, and then after the presentations at the end. So there'll be ample opportunity to ask your questions. So please do use the Q&A function in the Zoom platform, and that is the best way to get us your questions across. And then I will do my best to MC that and get the conversation going there. Just to preempt any questions, we will actually publish the final report in the coming days, towards the end of the week, if not latest early next week. So look out for that as well. But without further ado, I'm very pleased to bring to the floor Tom Smith, who is the president of COGEN World Coalition, CWC, to give some welcome introductory remarks. Tom, the floor is yours.
Okay, thanks, Hans, as always. Hey, how come you don't put that it's 7 o'clock in Chicago and we're even getting up earlier than Washington? But no, for those of you who don't know me, my name's Tom Smith, as Hans had mentioned. I'm the current president of the COGEN World Coalition. I also wear a number of other hats. I'm also the president of the Combined Heat and Power Alliance here in the United States, where I reside, and I'm also the senior director of energy development for Caterpillar Electric Power. So it's sort of an interesting time, and the timeliness of this subject is unbelievable. Every time I turn the TV on, all I can hear talked about is energy and growing energy demand, and the amount of power that data centers are looking to take. Today actually is probably the only day that I turned the news on this morning before this call, and I didn't see anything on this because we have something coming up here in the United States tomorrow, a little election that some of you may be aware of. But the interesting thing, if you go through some of the statistics, the global electric power demand is expected to increase by 150% by 2050, obviously representing thousands and thousands of megawatts of new demand. Just data centers alone, currently data centers use about 2% of the global energy today, if you include crypto mining. And if you look in the United States alone, data centers represent about 2% of the power that we consume in the United States, and it's projected to increase about 5-fold by 2030 to be almost 10%. And if you look at other countries such as Ireland, I think from some of the statistics that Simon referenced in his report, their demand is around 21% for just data centers alone. So if you look at how much power data centers are consuming, combine that with the global increase of power demands in general for electrification of everything, it's an amazing time for energy growth. And if you take a look at how that reflects combined heat and power, a little bit of history for those of you who may not know, 132 years ago, Thomas Edison built the first cogen plant in New York City and called the Pearl Street Generation Facility. That plant generated electric power, but the heat was also used for, heating of buildings in downtown New York. So if you look at the history of cogen, it's done great things for well over 132 years and has adapted to, many changes. Currently, cogen represents about 15% of the total electric production in the world. And if you look at what we've done for district energy, for pulp and paper, refineries, hospitals, commercial office buildings, CHP has been a very big portion of their thermal and electric power requirements. Now, if you look at data centers, representing, such a massive growth. And if you look at Simon's report, when it comes out, 50% of the actual energy use in a data center is used for cooling. So if you could put combined heat and power, which could generate electric power through absorption chilling technology, meet some of the cooling demands that a data center would have, you'd have a really cost-effective, efficient, and sustainable way of actually meeting a portion of the load growth that you're going to see with data centers. And if you think about it, if the data center load is going to grow as much as it is projected to grow, and we can even meet the saturation of around 15%, like we talked about, of how much CHP meets the world demand, that's going to represent, and I tried to do the math, but it's literally tens of thousands of megawatts of potential for combined heat and power. So with that, I'd like to turn over the presentation to the rest of the group. But before I do, I'd like to thank, Hans for all the work that he's done behind the scenes for COGEN Europe, and to thank Simon for the report that he's doing. It's so hot off the press that it's not finally complete. It'll be done probably by Friday of this week to be put out. And I'd also like to do a shout out to Alex and Klaus and Roberto, for getting on and talking about, how the industry can support, this growth. So with that, Simon, I'd like to turn it over to you.
Thank you, Tom. Let me just work out how to share. Okay, so good morning, those of you on the west side of the world. Good evening for those of you on the east, and good afternoon if you're in the middle bit. My name, as has been said, is Simon Minett. I'm Managing Director of Challoch Energy, and we were commissioned to look at the assessment for data centers and the role of CHP, or combined heat and power, or cogeneration, depending on how you wish to call it. But throughout this presentation, it will be called CHP. Okay, there's my contact details for those of you who want it. Any comments we'll try and take on board before we issue the final version of this report. As Thomas said, it's 90% finished, probably a bit more than that, but I wanted to keep it open to have this discussion, and then we can update it with any bits that come from the audience or from the other presentations today. Okay, so the presentation, it's about half an hour, and then there's plenty of time for questions afterwards. I'm going to look at the growing role and impact of data centers on the global energy market, and especially on power grids. Look at some trends and the projected growth. Explore some of the energy efficiency solutions, which to date have been less used than it could have been, I think is fair to say. And then focus at the end on the benefits of using CHP in this environment. So just to start with a few trends, as Tom's already alluded to, it's hardly a day goes by without some some comments about data centers, and rightly so, because it's a huge shift in the total energy requirements of the planet has really been driven by the growth of data centers and the growth of some of the technologies that are being used that need data centers. So data center demand growth since 2010 has increased 25-fold, which is an incredible increase when you think about it. And without data centers now, we wouldn't be able to survive in economies. It's become so fundamental to our way of life and the way we do business and the way we communicate with friends, loved ones, and colleagues, that without data centers being there, it really would make life very tough. Biggest driver in the market is the growth of artificial intelligence and things that are linked to that, of course, and that's driving data centers to bigger and bigger scales. Location hotspots at the moment, this doesn't mean it's going to stay that way, but the high concentration in the US, in Germany, UK, and Ireland. Ireland's a small country, but the amount of power that goes into data centers is very, very high compared to what you'd expect in a larger economy. This demand growth and the locations that data centers go in, so puts pressure on the infrastructure, on energy resources within the countries. Data centers tend to be sited where it's convenient for data centers to be, rather than where it's convenient necessarily for power to be supplied. So that drives a real challenge. We see things, and I pick out one small nugget here, that the Nordic market, so that's Scandinavia, is growing rapidly and is starting to challenge the capacities of places like Frankfurt and Paris. And that's partly driven by the fact that the Nordic market has available cheaper energy resources, so cheaper electricity than perhaps some other markets, at least in Europe. The size of data centers is getting bigger and bigger. You go back 10 years and you're sort of looking at 10, 15 megawatt sort of sizes, and then a little bit bigger. Now you're looking at schemes which are in the sort of 200 megawatt range. The 1 gigawatt data centers are on the drawing board, and I've even heard talk about 4 gigawatt data centers. And just to put it in context, the largest power station ever constructed in the United Kingdom was 4 gigawatts. It was a coal-fired station at Drax, and that's the power that data center would need, and it would need more than that power station because it would need secure power. Increasingly, we're seeing that data centers are developing their own power supplies because the grids can't keep up, and a bit more about that down the road. And then we've seen in the last few months increasing discussion about the use of nuclear for data centers. For example, 3 Mile Island with Microsoft discussions, and a lot of discussion around small modular reactors going into data centers to provide the power. Big challenge then in this process is we live in a world which is talking about carbon reductions and getting to net zero, whatever that may mean, within the next 20, 30, 40 years. And yet the thing that's driving data center growth is natural gas generation. So there's a challenge there, and also the data center users and the hyperscalers, which is sort of Microsoft and Amazon people, are talking about being zero carbon. So there is a really strong challenge in that with that last statement compared to what is currently being provided into that space. I include this, this is a single article in the Financial Times back in April this year. And I picked it out because just a couple of things in this process. Firstly, that Microsoft, Amazon, and Alphabet alone spent 50 billion in 2020 and is expected to spend 125 billion in 2025 on data centers. The graph on the right comes out a bit blurry because I blew it up just to give some scale, but you can see the total power capacity requirement for data centers in 2022, and it's much more now, is around 45, 46 gigawatts of power. And to put that in context, that's equivalent to the peak power demand in the United Kingdom. So that's a country of 65 million people, reasonable industrial base, and data centers globally now use as much power as the UK does on peak. As Tom has already said, globally at the moment, data centers require around 1 to 1.3% of total electricity demand. It's expected to rise to 2% in the US by 2030. In countries like Ireland, it's at 21%, and has sort of almost reached the limits of growth, I'd say, in terms of what grids can cope with and what electricity supply from the outside, without really radical thinking going on, where you have a lot of embedded power and you start providing flexibility services into the networks. And even that will reach a limit to growth in a small country like Ireland. The interconnections to outside of Ireland are not strong enough to cope with massive growth. Maybe I'm wrong, but that's my take on it. Also, a lot of these data centers are going in for corporate PPAs using renewable energy. You can see that solar and wind for Amazon, it's about 60%, 70% solar, and about the balance is wind. And the same sort of figures are true for the other hyperscalers. Expansion in the data center world, it's all about power capacity and floor space. It's all about size, and AI drives size and therefore energy use. And that has a massive impact on the infrastructure, on the grid infrastructure. You know, the bigger the scheme, the bigger the strain on the local electricity network, even if it's transmission connected supply, that takes a long time to come. So there's a disconnect between the desires of the data center developers to do this at speed versus the ability of the grids to actually be there at speed. So I've already mentioned the technical drivers. So growth in AI, cloud computing, 3G have all increased massively the demand for data center capacity. Energy demand is expected to double by 2027. And as I said, grid capacity lags behind. The graph below here just shows the growth of data centers in different markets. So you've got Q1 in 2023 in the dark and Q1 in 2024 in the light blues. And there's some ones that have sort of peaked and a bit less now, like London. And you've got places like Hong Kong, which is growing very, very rapidly. So you know, in this market. I thought it'd be interesting. This is a focus on the European Union, the EU 27, as it's called. So it's 27 countries that make up the European Union. And you can see the expected growth between 2024 and 2026. It's not as dramatic as it looks because the scale cuts off at 2,300 gigawatts, 2,300 gigawatts. So that's the existing stuff. And then you've got the growth of a whole series of other things in here. Electrification of industry, then electric vehicles, data centers, heat pumps, and others. So electric vehicles, it's a big trend in Europe to move from combustion engine vehicles to electric vehicles. And and yet that's only going to be about equivalent to the data center growth. So there's lots of other challenges that the electricity sector faces at the same time as the data centers are screaming for more power. Looking globally, as you know, this is a slightly different set of data. So 2 to 3% of total global power, and the IEA is projecting that to almost double by 2026, and that's from a base of 2022. So it's really dramatic. 4,600 terawatt hours. So the figure I gave you before, where I said 46 gigawatts, is the instantaneous requirement, and this is in across the year. Already said about the main drivers, and I just thought it'd be useful to just see the main cities that are there at the moment. This is from 2023. So London's very dominant in that. Beijing in China and Northern Virginia in the US are the big three global markets. But as you saw in one of the previous slides, Hong Kong's growing rapidly, and other markets also are growing rapidly. So you can sort of see that this is not going to be just in one place, and partly because of the ability to supply electricity into those areas, and then also, of course, available space for these centers to go in. Just looking at the European market for a moment. Ireland data centers use 3 terawatt hours, which accounts on an annual basis to about 11% of the national electricity. Seems to be slightly at odds, and I'll check that one when I revise the report. Germany's 17, 18 terawatt hours a year. Netherlands, it's 5.2% of national electricity use. Denmark, which is again only a country of 5 million people, it's over 1 terawatt hour. France is 2.2%. UK is the largest current market in Europe. And there are several 200 megawatt plus projects on the planning at the moment across the UK. And then just one example, Google's building a huge data center in a place called Skien in Norway. And that one will be 99% carbon-free energy, but that will use hydro as the hydroelectricity as the power source going into it. I picked some challenges and considerations. So AI has really driven data center growth, as I've said. Grid infrastructure, and this is just Europe, but you could repeat this in North America. 40% of the European power grid is over 40 years old. In fact, a lot of it's over 60 years old. And there's increasing constraints on expansion. It's very difficult to build new grids. It takes years and years and years to build new grids. There's been a discussion in Germany for at least 10 years now about having a new transmission line from north to south to carry wind energy down. It doesn't show any signs of ever being resolved, to be perfectly honest. So this is a huge issue for growth in this sector. And then energy security, so that's price volatility. It's also the security of energy supply, electricity supply. So again, I pick on Ireland. One consideration of some of the big data center operators in Ireland is the Irish electricity system secure enough for the next development of a data center without it being effectively island operations. So it satisfies itself. So all the power comes from on site. So much less reliance over time on the grid, and more reliance perhaps on doing it themselves, which of course is a significant opportunity for CHP. It's a significant opportunity for people supplying the energy equipment that's going to go onto those sites. But that also comes, of course, with space issues, because a significant amount of generation takes up a reasonable amount of space. Okay, so I thought it'd be useful before I talk about energy efficiency and grids and things, just to look at where energy goes in a data center. I'm not going to spend a lot of time on this slide, but you can see that the around about 50%, and it does vary depending on the data center, but around about 50% of all the electricity going into a data center is used for cooling, a little bit for lighting, there's a little bit for power conversion, and then about 38% is for the IT load. So significant ancillary loads compared to what its function is, which is IT. And cooling is by far the largest of those issues. So looking at the opportunities here, so I picked up three big opportunities. First one's on-site power generation. It's almost a must for some sites because you won't get a grid connection. It's a significant opportunity for things like CHP to supply both the power and to avoid using electricity for cooling, at least most of the time, where you could use the waste heat or the heat off the engines to provide that cooling through absorption chilling. There's an opportunity to go to zero, though that comes with its own challenges by using green fuels, for example, hydrogen and maybe carbon capture and storage. That will increase, of course, the operating costs based on against today's costs. You start to see opportunities, and I think you'll see a lot more of these, where it's effectively an off-grid data center campus, where the grid won't be available, maybe never be available for those sites, and that might drive you towards putting data centers in places like Morocco or the Middle East, where there's lots of space, and you've got significant amounts of natural gas available for the fuel. And then there's a few other bits and pieces there. And I think you'll start to see a big teaming up between energy companies and these large off-grid data centers. And it's not core business for the data center to do that, so they're probably going to outsource it to somebody else. Up until now, of course, you just buy the power from the grid historically. So yes, you ran your backup power, but this is where you're running power 24 hours a day, 7 days a week, and that's probably a service which the data center operators would rather not do themselves. So you're starting to see trends in that way. Okay, so I'd just like to spend a bit of time, and I've already alluded to this a few times on the impacts on the grid. Grids will need upgrading, modernization, however you wish to call that, to cope with these increased power demands. That's a very long period of time. So I had a conversation, not on data center, on something else, talking to the grid company about an industrial site wanting another 100 megawatts of power. And the comment back to me was, yes, that's fine, but we can't get it to you until 2040. And that was last year. So it's like 16, 17 years to wait for the grid company to be able to do that. And it wasn't a question of money, it was a question of availability of people, it was a question of availability of equipment, and it was lining up everything else that needs to be done at the same time. So that's overhead lines or new primary substations or whatever. So that's a big issue in terms of what you can do. And in some markets, it's much harder than in others. The third point here, which is resilience and the ability of the grids to provide that resilience, historically, of course, grids have always been backed up for data centers, that is, with backup power supplies, normally diesel-fired generation with stored diesel on site. That starts to come with some significant challenges in the future, because if you've got a 200 megawatt data center and you want to be able to have resilience for say 5 days or something like that, and and each data center operator has a different number for that, then you're looking at an enormous amount of diesel being stored on site to provide that resilience. So there's lots and lots of challenges in this process. But for me, the biggest issue is none of these. It's the time to, it's back to the time to connect. The lead time for grid upgrades is much, much, much longer than the patience of a data center developer. The data center developer will probably want to be up and running in 1, 2, 3 years, and the grid may take a decade or 2 decades to come to. So consequently, it's going to be a prime power market from now on, in my opinion, at least. So that's an opportunity for gas engines and gas turbines. And if and when the grid comes to that site, then that will be switched over to backup, or some combination where the prime power then forms some flexibility services as well. I don't want to dwell too much on this because I've already spent quite a long time on these issues, but prime power, that's CHP systems, renewables like wind and solar, that has challenges with intermittency. And nuclear are definitely in the frame. Hydrogen's really more of fuel than a system, of course. Backup systems with diesel generators, and perhaps a shift towards using natural gas instead of diesel as your fuel. But that also has some challenges. What happens if the gas system breaks down, et cetera, et cetera. So there's some challenges there for a data center developer. And finally, it's a question of redundancy. So if you go for a prime power system, you need a large level of resilience in that. So if you take a 40 megawatt block of a data center, and they're modular generally, so a 40 megawatt block is a reasonable size of power demand, that will require around about 60 megawatts of installed capacity to give you that redundancy, that resilience in the system. That's assuming it's a 15 megawatt generator going in. It changes a little bit if you've got smaller generators, but then the footprint of those smaller generators is much bigger. So there's always going to be a balancing process in that regard. This graph just shows you some of the impacts of an outage if the data center has an outage. The numbers are mind-boggling, to be perfectly honest. You have an outage in a power to a data center, and you can't keep the data center. You're into the millions and millions and millions of dollars of costs and lost opportunity. And as I said very early on, without data centers, without the cloud computing that we all now expect, economies just grind to a halt. What can you do when your computer's not going to work? We've become very, very reliant on this sort of technology. Okay, the last part of this presentation is to really pick up on some opportunities for waste heat recovery and then for CHP. There are, of course, significant environmental benefits from reusing the waste heat. So there's 2 ways of looking at this. The first way is to say that the chilling plant on a data center gives out heat that could be used by others, glass houses or district heating schemes or whatever. So that's one way of looking at it. The other way, of course, is to use waste heat from your prime power production to provide cooling into the data centers. So there's those 2 ways of looking at that process. And you see some discussion about both. You see some regulatory push, especially in places like the Netherlands, to actually reuse the heat that comes off a data center for schemes. It's still patchy, but you can see that growing and growing as the regulators and the policymakers' spotlight starts to focus more and more on the impacts of data centers and their carbon footprint and their energy footprints. But this is a target for them to recover that waste heat, or to supply the electricity that would have gone to make that cooling from waste heat sources from power generation. I just give you a few examples of where waste heat applications are being used. It's a bit difficult to read this slide, it's better in the report. But I'll pick a couple. So you've got a hyperscale data center here in Finland, and it's providing waste heat into a district heating scheme. That's at Yandex. And if I go all the way down here, then there's a lobster farming application here with a colo data center in Norway, and that's putting the waste heat into the lobster farming. So these are examples where the waste heat is being recaptured from the data center and put into an application. And as you can see, it's from district heating through agriculture, swimming pools, all the way through to fish farming. Okay, to the role of CHP, as this is the focus of what we were asked to look at. I don't think I need to tell anybody that CHP efficiently generates power and heat. It's the most efficient way of turning a fuel into useful energy. It's, as Tom mentioned at the beginning, it's about 15% of all power generation in the world is in CHP systems, and probably similar sort of proportion for heat, though heat is not always as easy to get hold of statistics-wise. This is a typical trigen system. So you've got the electricity production, you've got the waste heat going into absorption chillers, and then you've got additional waste heat, which is normally the stack energy, which is hard to get, but that can still go into district heating schemes with heat pumps. So there's some challenges for CHP in this market. First one, it has high initial investment costs, though that is not too much of a problem for data center operators, where those costs are not significant in the total operating cost of the data center. But it is an extra cost burden to find at the beginning with the waste heat recovery. There's still some issues with technical integration, and I'm sort of hoping that the other speakers will give us some examples of where that's been solved. And then there's some regulatory barriers towards this. Regulations forcing CHP is always generally weak, and it's easy to avoid doing that. And sometimes you go down different planning routes, et cetera, if you're CHP than if you're just doing something else. Three other points. So data center operators are not always aligned for CHP supplying cooling energy or base their power yet. They're more used to other solutions. Challenge for CHP plants, especially if it's running in a flexible mode, is the speed to response. You've got to be able to start up from cold within 1 minute, and 1 minute can be quite challenging for the CHP technologies. And then, as I've already mentioned a few times, the driver towards low carbon, zero carbon fuels. So there's discussion around using hydrogenated vegetable oil, HVO, biomethane, and hydrogen. But at the moment, there are availability challenges for some of those fuels, and they're not always in the right locations either. Market opportunities. This is a very significant market opportunity, I'd say, for CHP, because the growth will be prime power. So doing prime power and doing it properly with heat recovery and doing it as efficiently as possible has to be one of the key drivers for this. You've got the increased efficiency, you've got reduced carbon footprint, and you have lower operating costs, all of which are worth having. However, we found very, very few examples of CHP used in data centers. We had a really good look. There are some, but there are not many out there at the moment. So I think, examples are necessary, and without those examples, it's easy just to do what you did yesterday, if you see what I mean by not thinking about it. So we need those examples. We need those well publicized so that people, when they're developing data centers, start to think about CHP. And I'd roll one final thing into this comment. The people who develop the power island of a data center are focused not necessarily on doing the heat recovery part. So, because that's more into the data center itself. So it may be you've got different teams having to work together here to achieve this. And that in itself may be a barrier to development. Right, final slide. I'm again focusing back on the EU for now and looking at legislation. There is very little direct legislation affecting data centers at the present time. And we see that across most of the world. Data centers are just industrial users and they've sort of been left alone. I think that will change. There's some planning pressures in some of the member states of the EU that are forcing things to change, but it's still rather weak. We have the Energy Efficiency Directive, which has been enforced now for nearly 20 years, and the last recast of that happened and got put into place this year. And that's starting to require reporting on energy use, on sustainability metrics. It has a big focus on recovering waste heat. So there is one measure in there, but as I said, there's not a lot of direct legislation. I think the other thing that starts to drive this is industry compliance. So it's corporate sustainable corporate. What is the right word? ESG. I'm forgetting what the letters stand for at the moment. ESG and science-based targets, etc. So Scope 1, Scope 2, Scope 3 emissions. That is probably going to be almost a bigger driver than some direct legislation in this. It's looking better than your competitors. Okay, I've talked for long enough, so I'll stop there to take any questions. I assume, Hans, you'll be the funnel for questions for me.
Yes, but I suggest you click on the Q&A function as well. They're all written out there, but the first two questions are linked to the use of basically lithium-ion batteries to power data centers. I guess you alluded to that already in your slides in terms of backup capacity versus using diesel generators. And then also just using that to store intermittent wind and solar power.
Yeah.
In your research, did you see any literature about that?
There's a bit, but the amount, for these big data centers, the amount of batteries you'd need is so vast that you sort of probably not going to go down that route. But for smoothing power, yes. For critical UPS type situations, yes. But as a sole source of power or total backup power, no. It's the requirements are too big for the batteries to cope.
I suppose there's a grid issue as well. I mean, you need to charge those batteries, and the electricity has to come from somewhere.
Exactly. And but you can see how a battery would smooth if you had connections to wind and solar. Then the battery provides you with that sort of stability of power coming out from the battery rather than coming from the renewable generation.
And if I remember correctly from the report, I mean, batteries are already used in UPS mode in most data centers to provide that one minute of electricity whilst other systems come online. Yes,
indeed.
Okay. Well, maybe you can take a look yourself at the second question regarding a pie chart. Maybe let you take a look at it yourself.
So I was just finding the right button for the chat. Well, yeah. So this is questioning the pie chart split of electricity consumption, and saying that that cooling's less than 20%. I think that was traditionally true for smaller data centers, but for the bigger ones, the cooling demand goes up a lot because of the sheer density of the beast and the processing power. So as data centers get bigger and their processing speeds go higher, then the cooling needs get bigger. But we'll take a look and make sure that pie chart's right. I mean, it's always good to be challenged on these things. So.
Yeah, Simon, this is Tom, and some of the reports that I've seen, it ranges it from 30 to 50%, depending on the data center. To your point, you know, because some of the newer chips that are coming out have a lot more heat rejection than the older ones, so it varies based on the design and the location.
Yeah, and also just the sheer size of these data centers. It's a deep core building, so and you're looking at a footprint where there's no way that heat can get out without it having a cooling system. So it becomes a heat island as well.
So I've got a sort of an important question. Is that a real cat next to you?
Yes, it is. Yes.
Oh, I saw the head move. Thank you.
Yeah. It's a very spoiled cat because it lies on a cushion on our desk.
Yeah, I thought it was maybe something animatronic, but it looks
no,
like
it's definitely real.
Moving on to the next question. Yeah, there was a question regarding increased water use and absorbing chillers, and I guess water scarcity, especially in terms of producing hydrogen, climate change adaptation. What about the issue of water use?
It's clearly an important part of the system, and there will be some places where absorption chilling is not going to work, or and hydrogen production won't work because you won't get enough water. But what you're seeing a discussion at the moment is a lot of discussion about hydrogen production offshore. So using seawater as the water source, and then using potable water from seawater. And so water becomes less of an issue there. I can also see that might be a driver for some locations. And I talked about Morocco and the Middle East. You can sort of see these things being on the coast using seawater as, and then they're using some of the heat because you get 40-degree heat. You can actually desalinate seawater using that heat with a partial pressure system. So you can, I think we're a long way away from actually maturing where we're going here. So I think it would definitely depend where you are in the world. But I'm starting to see lots of questions from water companies about the use of water for hydrogen production. So if you've got that, then you're going to have the same for absorption chilling.
There's a similar question, I guess, what your feelings about trigeneration for data centers and the potential to make up some of the cooling via absorption chillers. I guess that's...
Exactly. Yeah, if you're going to put CHP plants on data centers, you have two options, I would say. The first option is, well, you have three options. The first one is you just put the technology in and throw the heat away, which is sort of what's happening now. Second option is you put the technology there and you use the heat for something else. So you co-locate the data center with a big industrial load. And if you think about an oil refinery or a large chemical site, its heat demand is many times more than its electricity demand. So you could site a much bigger cogen plant there than the site needs for power use itself, and it could export the power to the data center. And the third one then is to turn the waste heat from the generation cycle into cooling, which is trigeneration.
Okay.
And given where data centers tend to get put, I think that one's the most likely, to be honest, because co-locating two industries together is always fraught with a certain amount of challenge because of business requirements and costs of infrastructure and stuff like that.
Okay, thank you. Not a question here in the Q&A, but it's something that came up in my thoughts when you were giving the presentation. You mentioned obviously that the capex is a little higher than other technologies. is there any literature or any appetite from what you've seen in terms of maybe operators of data centers using CHP to also somehow remunerate themselves through ancillary services, so allowing the CHP to operate flexibly whilst providing power and cooling, and then also providing some ancillary services to make up for some of the upfront costs?
You don't see much that's out there in the literature on that. Personally, I think the high capital cost is probably less of an issue. Upfront cost is less of an issue. Might be the time to put the plant in, and that integration issue with the site itself, rather than just being a power island. You are starting to see in some markets the requirement for where it's grid connected as well, being operating flexibly. So the ability to actually, when the grid needs power, the data center coming off the system and running up its power plant at that time, and then when the grid's got surplus, then pulling down again. I can't say too much about that, because what I know about that, I'm not allowed to talk about any more than that, to be honest. But you are starting to see those sorts of things bubbling around. Ancillary services, if that's flexibility services and things, I've just covered that. If it's other stuff, then I think it's a little bit in the weeds, to be honest. The energy costs and the operating costs of a data center dwarf the benefits of doing the other bits. So they're going to be, unless they're really easy to do, they're probably not going to be followed up.
Okay. Also, a question from my side, because looking at the participants, I saw some representatives of other technology providers. You mentioned engines and gas turbines, and Steve. Have you seen anything in terms of fuel cells in respect to data centers? And is there a potential market for that as well? Maybe smaller scale?
Yeah, I focused a lot in the presentation on the upscaling of data centers, but that's not the only market. You'll still get the small ones. We've seen nothing about fuel cells, almost nothing about fuel cells in that. It doesn't mean it shouldn't work, because it's highly efficient. Yeah, there's opportunity there for fuel cells. Power density is good, efficiency is good, but not much yet. And that may be because it's just they're more expensive systems than gas engines and gas turbines. You are starting to see quite a lot of discussion around nuclear in that process. So SMR, so small modular reactors, are definitely being discussed a lot. And actually siting data centers next to old nuclear power plants. So that's like the 3 Mile Island example. And what you might find in that process is, in some markets, actually putting the data centers on old power station sites, which already have the grid capacity, because that used to export, and now you just want to import. I think there are a lot of challenges with that, because of the nature of the power station site might not be suitable for data center, or it might be in the wrong place for interconnectivity into the cable system for the data. Yeah.
Okay, I think we have time for one more question, and it's a good question, because I do recall that being referenced in the report. So can data loads be switched to other data centers to shed loads? I guess it's sort of like a virtual power plant concept, but for data centers. So they could sort of plug and play and shed power loads when needed.
I think that's already done, to be honest. I think Amazon and Microsoft and the big ones do that on a regular basis.
Okay.
For the colos, where you've got co-location ones where the European Union might take a chunk of a data center, it's unlikely to be able to be moved somewhere else. So I think it depends, but certainly the big operators already do that.
All right. Thank you. And it wasn't in the slides, but I'll just tell everyone to look at the report when it comes out, because there was a very good comparison with electric only versus CHP and a cost comparison. So I encourage everyone to take a look at the report and take a look at that table comparing the two solutions and the total costs as well. I think it just demonstrates.
I just want to take the liberty, I guess, being the president of the CWC, maybe to sort of end with just a thought for Simon. I guess with the massive load growth that you're seeing in data center and the historic way that they've obtained power by tying into the grid and putting backup diesels, now that we're seeing a 5 to 10 to 20 to 30% growth potentially per year, wouldn't you say that the time to look at every technology to meet the demands of data centers is here, and that CHP should play a portion of that, if not a significant portion, just because of the efficiency and all the other things you referenced?
I couldn't agree more, Tom, to be honest. I think that's exactly right. And I think the impact of this capacity required drives you to efficiency, because if you don't need to supply that cooling load with either grid power or prime power, because you can get it from the waste heat, then the amount of power you're importing on hour by hour is less, and you might still need the capacity just in case the CHP plant is down, and you probably wouldn't just rely on absorption chilling as the only source of cooling. You might still have your normal electric chilling plant, but that would be the resilience within the system. But the impact of using CHP and the 50% gain in efficiency that CHP brings, so 100% gain in efficiency depending on how you look at it, but you double the efficiency, don't you? Then that's got to be a big driver in this system, and you can sort of see that authorities may start to wake up to that thing and start forcing it.
Thank you.
All right, thank you so much, Simon, and again to everyone online, look out for the final report that should be coming out at the end of this week or latest early next week.